In this lecture, we'll cover the topic, How to Learn Effectively from Video Courses. A short practical course on how to get the most out of video lectures. Scientific learning principles adapted for the video practices format.
That familiar feeling. You watch a lesson and feel like you understand everything. But this is deceptive. Our brain confuses recognition with true understanding. Passive listening is like studying a map instead of actually traveling the road. You think you know the way, but in practice you might get lost. This illusion hinders real learning progress.
Our brain is designed to retain information only through active engagement. Without questions, reflection, and application, knowledge remains in short-term memory and quickly fades. Passive learning doesn't create strong neural connections, which is why simply listening isn't enough for true material absorption.
Numbers speak for themselves. Research shows that passively acquired information is lost 50–80% within a day or two. This is why it's hard to remember details after a regular video viewing. Active learning methods increase retention rates by 3–5 times. That's a huge difference in effectiveness.
The forgetting mechanism works against passive learning. Without active participation, the brain doesn't consider the information important and quickly removes it. Research confirms that after 24 hours, only 20% of what was heard remains. This explains why simply watching videos is not enough for real learning.
Try an approach that changes everything. Imagine you're not just a viewer, but an active participant in the conversation. Before starting the video, ask yourself, what do I want to learn from this lecture? While watching, pause, ask questions to the lecturer in your mind, predict what comes next. This immediately changes the level of engagement.
Here's a practical method that truly works. Pause the video after each meaningful block and write down 3 things. The main idea in your own words, a specific example, and a question that arises. This approach creates neural connections and transforms external information into your own understanding.
The statistics are discouraging. When passively watching, the brain only retains 10% of the information. Without active participation, knowledge quickly fades. The active pause method is a simple way to transform superficial familiarity with material into deep absorption. Try it. The results will surprise you.
The key is not to wait until the end of the video, but to break at natural content breaks. Pause every 3 to 5 minutes after each conceptual block. This allows the brain to process information before receiving new knowledge and prevents cognitive overload.
During breaks, don't just rest, actively work with the material. Explain concepts out loud in your own words, as if you were teaching a friend. Solve a micro task or provide your own example. If you can't explain it simply, that's a signal to review the section again. This practice strengthens understanding.
Imagine that each concept is a piece of a puzzle. Before taking the next piece, make sure the current one is well understood and in its proper place. This way you build a complete picture of knowledge without gaps. This approach prevents the accumulation of misunderstanding and creates a solid foundation for further learning.
The Ebbinghaus forgetting curve is especially relevant for developers. Code and concepts fade away without systematic repetition. Passive lecture viewing doesn't create strong neural connections. Spaced repetition is a scientifically proven method for transferring knowledge from short-term to long-term memory.
Here is an effective system based on memory research. First, repetition after a day. Reproducing code from memory. Second, after 3 days, practice with modification. Third, after a week, solving a new problem, using the concept. These intervals are optimal for solidifying programming skills.
Let's look at an example with bubble sort. On day 1, we study the algorithm. On day 2, we write the code without peeking. On day 5, we modify it for reverse sorting. On day 12, we apply the principle to find duplicates. Each repetition deepens understanding and strengthens the skill.
Knowledge without application remains an abstraction that is quickly forgotten. This is similar to studying for a driver's exam without ever driving. The theory is there, but there's no skill. Passive consumption of information doesn't turn into ability. An immediate transition to practice is necessary.
Is how to transform knowledge into skill. Right after a lecture, create your own examples based on what you've learned. Test your understanding by explaining the material to someone else. This cycle, theory, practice, check, creates strong neural connections and true competence.
A concrete example of transformation. After learning bubble sort, write your own implementation right away. Once you understand the principles of object-oriented programming, create a class from scratch. After mastering SQL, write a query to a real database. This immediate application turns theoretical knowledge into a practical skill that will stay with you for a long time.
Beginners often fall into 3 traps. Multitasking reduces absorption by 40%. Skipping practice makes viewing useless. And the illusion of knowledge creates false confidence. Remember, I've seen it is not the same as I can do it. Avoid these mistakes for real progress in learning and true mastery of the material.
The brain cannot effectively process multiple complex tasks simultaneously. Switching between video and social media creates cognitive overload. Each such switch requires 15 to 20 minutes to fully regain focus. Single tasking is the key to deep learning and quality absorption of material.
Viewing without practice is like trying to cook without ingredients. The recipe is clear, but the dish won't turn out. Without immediate application, knowledge fades within 24 to 48 hours. Practice is the bridge between passive information and active skill that stays with you for a long time and can be applied to real-world tasks.
Test yourself immediately after viewing. Can you explain the concept in your own words? Solve a practical problem without hint. Use the Feynman method. If you can't explain it simply, you don't understand it fully. This self-testing breaks the illusion of knowledge and reveals your actual level of understanding.
Spaced repetition is like regularly committing knowledge to memory. Your calendar becomes your version control system. Each scheduled session is a merge of new knowledge with your existing base. Without this approach, knowledge leaks away like unsaved changes in code, and you lose a significant portion of what you've learned.
Group related topics into review blocks. For example, Python functions and decorators in one session. This creates meaningful connections and reduces cognitive load. Use tags in your calendar for categorization, Python basics, algorithms, databases. This approach makes your review process systematic and effective.
Instead of vague review Python plans, schedule specific actions. Solve 2 recursion problems or write a logging decorator. Specific tasks create measurable results and focus. Use the Pomodoro technique. 25 minutes on a task plus 5 minutes for reviewing results.
Now your brain is not a passive viewer but an active constructor of knowledge, gathering information like puzzle pieces. You've transformed the lecturer's monologue into a dialogue with the material, where each pause is a step toward mastery. You've mastered a system that turns theory into sustainable skills while avoiding the illusion of competence. Now you're ready to apply these principles to any course, creating a solid foundation of knowledge that won't crumble over time.